You're trying to learn the most with the least number of experiments. So what we're always trying to do is we're trying to use the minimum number of experiments that's going to tell us what we need to know. And so if you were to run every single one of those design points, then you're not just asking which factor is important. You're not just asking which two-factor interactions might there be. You're actually saying, I'm going to test for a six-factor interaction, right? So this is an incredibly deep level of interactions in a system, one that we've never seen before within Synthase, just to be clear. And we've run very dense designs over many, many factors, and the most we've seen is a four-factor interaction. So this is where, a three-factor interaction is basically a two-factor interaction, the nature of which changes on the basis of the level of a third factor, and so on, right? So it just gets more and more complex. To put it another way, if you're to run all of those 64 experiments, you're saying that you think that irrespective of what happens in all of 63 of those runs, one of the 64th is going to behave in a completely non-predictable way, right? And so what you can actually do is you can do what's known as a fractional factorial design, where you systematically and very carefully pare down these designs so that then maybe you can run 16 of these runs or 32 of them or some other fraction. And that will still then allow you to identify which the most critical factors are and maybe some of the most important interactions within that system. So, there's a certain pragmatism, I guess, in here.